Hi, I'm Tom Lee and welcome to my math class again. In today's tutorial, I will show you how to solve the first order differential equation and the second order differential equation as well. I will teach you different ways to solve the differential equation. One way is by integrating factor and the other way is by Laplace transform. In the second order differential equation, just like this equation, I will solve it by the first way by let y equal to e to the power ax. A is any constant, and I will show you how to using the Laplace transform to solve the same second order differential equation with the same initial condition. Now we jump to the question 1. We want to solve the first order differential equation by the integrating factor. If we want to solve the first order differential equation by the integrating factor, first of all we have to write equation in this form. It's y dash plus some function of x multiplied by y is equal to some function of x. Now we can see that the above first order equation is with the same form of this. So we write down y dash plus 2y equal to 4t e to the power minus 2t. And so now we're using the integration factors. A function of t, we call it I of t, is equal to e to the power of integration of this qx by dt, and of course in here is not qx, is qt should be, so I change it to t. So in this case the qt is equal to 2, so e to the power of integrations of 2 dt, so it's equal to e to the powers of integration of 2, so we have 2t. This is called the integration factor it, and we multiply these factors into this equation here. So multiply of it into the above equation, we can get it is e 2t y dash plus 2e 2t y equal to, if you multiply this by 2t you got 4t, and then we integrate the left hand side and the right hand side at the same time. So we integrate the left hand side, we got e to the power 2ty differentiation and integrate by dt, and with the same at the left hand side dt. So after you integrate this, the left hand side will be e to the 2t y equal to 4t squared over 2. Don't forget the plus c. C is a constant. After we get this, we divide both sides by e to the 2t. We have y equal to 2t squared e to the minus 2t plus c e to the minus 2t. And then we substitute the initial condition into the above equation. We have y0 equal to 3. So when y is equal to 3, t is equal to 0. And substitute 0 in here, we got 0 plus 0 in here, we got plus c. So c is equal to 3. Then the general solution is y equal to 2t squared e to the minus 2t plus 3e to the minus 2t. So we have done. Okay, this is the ways we solve this first order differential equation with the initial condition y0 equal to 3. Now take a break and we go to solve the same equation by the Laplace transform. Okay, after the coffee break, we go back to this solving the first order differential equation, but this time by the Laplace transform. We solve y dash plus 2y equal to 4t e to the power minus 2t with the initial constant y0 equals 3. We take both sides by the Laplace transform. We have the Laplace transform of y dash plus 2, the Laplace transform of y equal to 4, the Laplace transform of t e minus 2t. And now I'll remind you what this Laplace transform is. First of all, the Laplace transform of y dash is equal to s multiplied by some function of s minus y0, and the Laplace transform of y is equal to some function of s, and also the Laplace transform of e to the power at is equal to 1 over s minus a. The Laplace transform of e to the minus 2t should be equal to 1 over s plus 2, because a is minus 2, so is minus a is plus 2. And also the Laplace transform of t itself is equal to, let's see, the power of t is 1, right? So it's equal to 1 factorial over s to the power of 1 plus 1, so it's powers of 2. So it's 1 over s to the power of 2. And how about if we multiply this one to this one? We make Laplace transform of t to the power of 1 e to the minus 2t. We just substitute s plus 2 into this equation. We got it. So we have 1 over s plus 2 to the square. This is the Laplace transform of this one. You can see this one. So the whole equation of this Laplace transform, we got Laplace transform of y dash. So it's s multiplied by phi of s minus y0, and then plus 2 Laplace transform of y is some function of s, and then the Laplace transform of this is 4 multiplied by this one, 1 over s plus 2 square. Okay, so we make everything out. Y0 is equal to 3 is the initial condition. Y0 equal to 3, so we have s to some function of s minus 3 plus 2 to some function of s equal to 4 over s plus 2 to the square. And we take the phi s out. We got phi s multiplied by s minus s plus 2, and minus 3 is equal to 4 over s plus 2 square. And then we have phi of s multiplied by s plus 2 equal to 4 s plus 2 to the square plus 3. And then continues, we divide each side by s plus 2. We got phi s equal to 4 s plus 2 to the power of 3 minus 3 over the s plus 2. And now what is the inverse function of Laplace transform of phi s? It should be equal to yt, right? And we take this inverse function of Laplace transform of right hand side as well. So we have 4 over s plus 2 to the power of 3 minus, no, this one should be plus 3, the Laplace transform inverse of 1 over s plus 2. Okay, now we try to solve these two terms here. This term 1 and term 2. The term 2 is easy, right? So the term 2 is the inverse Laplace transform of 1 over s plus 2 should be equal to e to the power minus 2t. But how about this term? We know that the Laplace transform of, we take this 4 out, 1 over s plus 2 to the power of 3 is equal to 4 times the Laplace inverse transform of 1 over s plus 2 to the power of 1 plus 2. And we know that to the power of 1 is e to the power minus 2. And how about this one? Take square here. Take square here should be the t square outside. So we got 4t square. S plus 2 to the square should be t square outside. And inside is the e to the powers of minus 2t. So this one is this term here, and this one is this term here. Therefore, y function of t is equal to 4t squared e to the power of minus 2 plus 3 e to the power of minus 2t. So we check this answer with the answer in the previous question, 4t squared e minus 2t plus 3e minus 2t. Is this 4t squared? No, it's not 4t squared. Forget this. When you take the t squared out, you have to divide by 2. So this one have to divide by 2. So the answer should be 2t squared e to the minus 2 plus 3 e to the power of minus 2. And this is actually the answer. And we check this answer with this answer here. 2t squared e to the power of minus 2t plus 3 e to the minus of 2t. So in the first section, we use the integration factor to solve this first order differential equation. And in this question 2, we solve the same question, but this time we're using the Laplace transform. Which one is easier? Just depends. Sometimes this one is easier, and sometimes this one is easier. If you do it by the Laplace transform, you have to remember some equation of the Laplace transform. This makes the Laplace transform is more difficult in general. So this is for today's tutorials, and in the next tutorial I will show you how to solve the second order differential equation in two ways. One way is that we let y equal to e to the power of at, and the other way is that we are using the Laplace transform as well. So stay tuned to my tutorials. If you like my tutorial, please give a like and subscribe to my channel. See you then. Bye bye. Adios. Hasta la vista.